This is my Magic Shine Ray 1600 and it's a very high-end bike light, but it's got a bit of a rattle to it and it no longer turns on and off. So let's see if we can fix this and possibly upgrade it.
The first step in any repair like this is obviously to crack it open, and I don't really know how to do this, but I just figured if I pried the back off with a screwdriver, I'd get inside. Luckily for me, this is the correct way to remove it, as it's just press fit.
Ah, look at that.
With the back of the light removed, I was faced with 3 screws, so I removed them as well, and at that point, there was nothing that I could see holding it together. After trying various techniques and a quick motivational speech,
Fucking focus, man.
I decided that force was the correct answer.
What could possibly go wrong except literally everything? Oh, apparently nothing. Aha, look at that. Look at that. Alright, we have the internal board out. This board is pretty simple. Let me go over it quickly. Over here we have the charging and power bank section. This uses a buck boost / boost converter to have both a step down converter for charging the battery, but using the same inductor as a step up converter to charge devices plugged into the USB-C port. In the middle we have our LED drive circuit, and this controls basically the exact same thing as the USB, but powering for the LED rather than other devices. We have our 2 boards here, and they're connected to microcontrollers in order to allow it to cycle through the specific modes. None of this circuitry is broken though. The solution is actually on the back side of the board and far more simple. The connection on this battery has broken.
Yep, so glad I traced out the entire circuit to discover this fault. Well, there we go, that's electrical engineering for you.
Now that we understand what the issue is, it's time to talk about solutions. Obviously, we're going to be replacing batteries, but with which ones? It is worth noting at this stage that even if both the cells were good, I would still replace them both. If you don't, you can cause all kinds of issues, not to mention the fact that lots of current would flow between the cells if they're different voltages. When it comes to choosing new 18650s, not all are created equal, and you have to choose ones which will work with your device. Now, the most important thing when choosing cells is that they have a higher continuous discharge rate, the same or higher I should say. Now, you could calculate what the continuous discharge of this is by modelling the circuit and doing the maths. Or you could look at what the original batteries have, in this case 5.2 amps. So we need a continuous discharge higher than 5.2 amps. That's basically all there is important. However, larger capacities will make your device last longer. I'm personally going to be using the LG M29 cells. These have a slight capacity boost over the original, 2,900 mAh as opposed to 2,600. I personally didn't notice battery life issues on the Torch, so I didn't think upgrading the capacity was necessary. I typically use it to ride home from work, and I don't need that much battery life. But let's talk about if you did want to extend the battery life. If you want to increase your battery life, I recommend, for a cost-effective option, the LG MH1s. These have 3,200 mAh of capacity, which is significantly more than the 2,600 in the original cells. They're pretty decent, however, they are a little bit more expensive than the ones I'm using. Also, they have a slightly lower maximum discharge. This isn't going to be an issue because we're well within that. But it's just something to consider if you want to buy them in bulk and use them for your other project. If you really want to increase the capacity, the LG MJ1 is a great option. They're more expensive, but they have a 3,500 mAh capacity. So they're a really good option to increase it. 3,500 is pretty much the max you can get in a 18650, and they're pretty cheap.
If you're following this as a tutorial, hopefully you've chosen your cells by now. The next step is of course to remove the old ones, which I did by desoldering the nickel from the circuit board. Rather annoyingly, in the factory, they used 5mm nickel strips, and I don't have any 5mm nickel strips. So I cut a kind of bat shape, I'd say, out of some 10mm nickel, and I'm going to use that instead. I began by soldering these tabs onto the circuit board so that it would be easier to hold them in position. Then I wanted to spot weld the batteries on. And in order to do this, I acquired myself an AliExpress spot welder so that I could show people who don't have access to the more expensive ones that it's possible. At which point I discovered that AliExpress ones are 1/10 of the price for a reason, and it was terrible. I did one battery just to prove it was possible, and it was quite difficult. But then I gave up and used my proper one for the second battery. With that replaced, it's now just a question of putting it back together, which is quite easy. You slide it back together, do up the screws, and press the back on. And now we have a working light.
Well, there we go, it's fixed, and I've actually jammed it in the back of a softbox to film this outro, just because, well, I can, and I was lazy and couldn't find another light to put in there. So here we go, lighting up. I am being entirely lit just by the magic shine jammed in the back of the softbox. All in all, I'd say this video was pretty easy, hopefully helped you out.